Before we start our lessons, hello, Kai. Before we start our lessons, I want us to talk about our assessments. Today, you are doing your technology assessments, and this is the announcement that I was given to pass to you about assessments. You are supposed to do the assessments at your own time and submit by 22 hours tonight. So the assessments must be submitted tonight, by 22 hours. Right. What you are supposed to do to submit is to click a submit button at the bottom or end of the test, and that will automatically send the test to the school. And you can choose to email, right? At the bottom on the right-hand side of the test, you can click there, and then you will be sending the test to the school. Right. You must send once or twice to make sure that it's fine, but not more than twice. Okay. It's imperative that you submit today. If you don't submit today, 20% of your marks will be deducted. So you don't want to lose your 20% of your marks, please. So do the right thing. And for the drawings, you will be required to draw. For the drawings, you will do this. You will draw on a piece of paper neatly and upload it. You are going to take a shot of your drawing, and then you send it to photos. You send that as a photo, and you click at the bottom of the test, the right hand bottom of the screen, and then you upload that screenshot. Okay, and I hope you will be successful in your assessment, because we have revised a lot for the assessment. Okay, now welcome to this lesson of electrical systems and control. This is what we are going to do. We are busy from even yesterday, we're still busy with Ohm's law, resistors, calculations, and today we'll be doing electronic components. Don't send it to me, because if you send it to my email, it will not be on record on the school records that it was submitted, you know. So you need to submit to the school. You will learn calculations of voltage, current, and resistance. Okay, you are going to learn also about electronic components. Right. From yesterday, we are doing this. We were doing the relationship. We are doing the calculations of resistance, current, and voltage. And this is the formula. This triangle, I love it because it just helps you remember the formula. That for resistance, you have to divide voltage by current. For current, you have to divide voltage by resistance. Okay, for voltage, you have to multiply current by resistance. So if you keep this triangle in mind, you have a good departure in your calculations of Ohm's law. Right. What does Ohm's law say will change in a circuit when there is We are just revising what you did yesterday to make sure that you know it, and then we can proceed. What does Ohm's law say will change in a circuit when the resistance is kept constant, but the number of cells in series is increased? What will change? What will be the change? What will change? The current will change, okay? Yeah, so the explanation is that current is always directly proportional to voltage. If you increase voltage, then the current increases too. So when you're adding the number of cells, you're increasing the voltage, so the current will also go up. Right. How will the current change if the voltage supplied by the battery of cells is kept constant, but the resistor is replaced by another resistor with a lower resistance? How will the current change if the voltage supplied by the battery is kept constant, but the resistor is replaced by another resistor with a lower resistance? What will happen to the current? This is what you did yesterday, grade 9. There will be, Tandu is saying there will be more flow of current. Okay, let's see. The current will increase. Right, how would you describe the relationship between the current and the voltage in a circuit? I've given you the answer for this one. How do you describe that relationship? How do you describe the relationship between current and voltage? What is their relationship? The answer is even in the answer of the first question. What is the relationship between current and voltage in a circuit? Current is always proportional to the voltage if resistance remains constant. Very good. Very good, Cleo. Okay. They are in direct proportion to each other. When the one changes by a factor, the other changes by the same factor. Okay. Right. Understanding Ohm's law, which of these changes will cause the current through an electrical circuit to decrease? Write down all the letters of the statements that are correct. A decrease in the voltage, a decrease in the resistance, a decrease in the voltage, an increase in the resistance. Which one of these will cause the current to decrease? It's A and D. You're correct, Amraha. It's A and D. Tandongubane is A and D. Okay, because when we increase current, when we increase voltage, the current increases. Okay, so a decrease in the voltage will decrease the current. An increase in the resistance will also decrease the current. So it's A and D. Right. An electrical circuit has three 1.5 volt cells in series that is connected to a lamp and a resistor in series. Which of the following things would cause the lamp to shine less brightly? Write down the letters of the statements that are correct. An increase in the voltage of the battery. Add another cell. A decrease in the voltage of the battery. Remove a cell. A decrease in the resistance of the resistor. An increase in the resistance of the resistor. So Tando, you're correct. It's B and D. It's B and D. If you decrease the voltage, the output will show. If you increase the resistance, still the output will show. So this will make the light shine less brightly because it is the output component. What will the potential difference be if the current in a circuit is 10 amps and the total resistance is 1,000 ohms? So we are, what is it that you are calculating here? Are we calculating current, voltage, or resistance? Which one are we calculating? We are calculating voltage. You are correct. So, what is the formula that we are going to use for calculating voltage? What is the formula for calculating voltage? We are going to multiply current by resistance. Okay, let's see. What will be the answer? Yes, you're correct, Tando. Voltage to current multiplied by resistance. So what will be the answer here? A 10,000 volts. Okay, you multiply this current by the resistance, then there's your answer. Your answer is 10,000 volts. So the key thing here is to remember your formula. Okay, given a voltage of 10 V and a resistance of 1 kilo ohm, what will be the value of the current be in a circuit? And remember, a kilo ohm is what multiplication is that? A kilo ohm. It's 1 kilo. It's how many ohms? A kilo ohm. It's times 1,000. Okay, it's times 1,000. Correct, Tando. So, what will be the value of the current in this circuit? So what is your formula? Current equals to what? Yes, voltage divided by resistance. So multiply. Divide. Voltage divided by resistance. Calculate. Your answer is this. Okay? Because 1 kilo ohm is 1,000. So that will be your answer. You must first work on the kilo ohm. Okay? Because this is not 1, it's 1,000. All right? And your resistance Your resistance is 1 kilo ohm. Okay, yeah. Yeah. And the 10V, not 10.9, it's 10V. Okay, 10V divided by 1,000 ohms. That gives you 0.01 amps. Right. Given voltage is equal to 20V and resistance is 5 kilo ohms. So 5 kilo ohm is 5,000. So for the current, 0.004 amps. Okay. A tumble dryer in a laundry service uses 22 volts power source. The coils of the heater provide an average resistance of 12 amps. What is the current flowing through the heating coils? So you calculate current here. So your current is your voltage divided by your resistance. Calculate. Let's see. Yes. 18.3 amps. You're correct. You're correct. Yes. A 9V battery maintains a current of 3 amps through a radio. What is the resistance? Calculate your resistance. So your formula for your resistance will be your voltage divided by your current. Okay? Your voltage divided by your current. Calculate. Three ohms. Yes. You see, when you remember your formula, you can quickly do your calculations. If the voltage across a circuit is increased 4 times, what would you expect to happen to the current in the circuit? So if you understand the relationship between the two, then you can answer. If the voltage across circuit is increased 4 times, what will happen to the current? It will also increase 4 times. That's good. Yeah, so we can go past this now. What do you feel? You understand this, ne? As long as you understand the formula, then you can give, you can do the calculations, because you'll be given, yeah, you will be given the values of the other, the other variables, okay? This is your circuit. Your circuit, in the circuit below, calculate the value of the resistor. Calculate the value of the resistor. Okay? So, your resistance is your voltage divided by your current. Okay? So, your voltage divided by your current. That is 6V. This 9 is supposed to be a V. I'm sorry about that. 6V divided by 2A. That gives you 3 ohms. So the value of your resistor will be 3 ohms. Then you have your switches. Your switches, a switch controls the electric current by closing or opening the circuit. There are various types of switches that control the circuit in different ways. In this lesson, you will learn about manual switches that a user can turn on or off. Okay, let us look at this switch. Right, this is a push button switch. So there's the switch. The red button there is what you push to get the current to flow in this circuit. All right. And because it's a doorbell circuit, you have your buzzer. There's your buzzer there. Okay. You have your buzzer, sorry, as the output component, and you have this push button. So the person at the door will be pushing on this red button, and then this buzzer will go off. Okay? Right. So we have a single pole, single throw switch. This is how we draw it. A single pole, single throw switch. Okay? So this is what you find in the circuits that we have been showing in the other slides. It's a single pole, single throw switch. Then we have a single pole. You see, a single pole, double throw switch. You have one pole and two throws. Okay, so this switch can control current from this first throw or control current from this second throw. So it's a single pole, double throw switch. Right, let's look at the application of these switches. Now, a circuit with a single pole double throw switch is like this one. It is called the SPDT switch. It's a single pole, double throw, single pole, double throw. You look at the first throw labeled A. You have an output component there. And what is this output component? What is this output component? What is this output component? It's a light bulb. This is a light bulb. So you have this output this way. So when you want to connect current to this output, you will put the pole on this throw. But when you want to activate this output, you will put the throw on this, the pole on the throw labeled B. So that is how this single pole double throw switch works. Okay? And you also look at the other components of the circuit. You have your 4.5 volt power source there and two output components, and they are arranged, they are connected in parallel in this circuit. So this is one parallel circuit. Okay, so the single pole double throw switch can function in a parallel connection of output components. Okay, did you understand that? The single pole double throw switch. Then you have a double pole double throw switch. How can the direction in which the motor turns be changed? The way to do this is to change the direction of the current through the electric motor. Because even this single throw single pole double throw switch, it does change the direction of the current, because if you put it on throw A, then the current is going to this output. If you put it on throw B, the current is going to another output. So it does change the direction of the current. Now, the way to do this is to change the direction of the current through the electric motor. A double pole, double throw switch can be used to reverse the direction of current through a circuit. So they are useful in applications such as automatic car gates. Okay. The circuit diagram in the next slide shows how a double pole, double throw switch can change the direction of current through an electric motor. This is only a symbol, okay? The graphic symbol for the double throw, you have two throws, you have double pole, you have two poles, and you have two throws, okay? Let's see, this is the circuit. A circuit with two, this one is with two single pole double throw switches. Right, let us look at it, because we have two of these circuits. Now, two of these switches. A circuit with two single pole double throw switches is often used to control a lamp with one switch at the end of a long passage. In your house, for instance, in your house, it is also used to control a lamp with one switch at the bottom of a staircase and the other switch at the top of the staircase. I hope you understand me. Like, imagine in your house, if you have a big house, it's a dark. You enter the house, you are at one end of the passage and the light is there. So when you are entering the house, you are going to turn the light on from this side, okay? You turn the light on this side, and when you are at the other end of your passage, you can still turn the light off, okay? Because the output component is 1, but because of the distance, you need 2 switches. That's why they made an example even of the staircase. If you go up the staircase and it's dark, you can switch the light on at the bottom of the staircase. And when you reach the top, maybe the first floor, you want to turn off the light, you can use the switch on the top, on the first floor, to turn off the light. Okay, so you have 2 switches for one output component. So you have a single pole double throw switch. Okay. All right. So you can have this is the throw. It's A, the pole, B, C. It can either be here or there. And this side, it can either be here or there. So it's your single pole double throw switch. And then how do double pole double throw switches work? A circuit where a double pole double throw switch controls the direction in which an electric motor turns the opposite direction. Okay, I'm sorry about that interruption. The circuit diagram, okay, a circuit where the double pole, double throw switch works. It's like this. An electric motor turns opposite direction when the current passes through it from terminal M2. Where is terminal M2? Okay, here is terminal M2. Okay, this is the terminal M2, and then the current passes from terminal M2 to terminal M1. Here is terminal M1. So this is the motor. This is the graphic symbol for a motor in your circuit diagram. Okay, and then to 4, there is 4. Okay, to 2, there is 2. Okay, and back to the negative of the battery. There's your battery. There's your battery. So this is your negative terminal of the battery. Okay, the circuit diagram below shows how a double pole, double throw can change the direction of current. Okay, so there is your double pole, double throw switch. Okay, there it is. This is just a single pole. This is the first switch, the single pole, single pole, single throw switch. But from there, this will operate in a way that you can have the current flowing either from this way to this way and that way, or from this way, okay? And when the pole falls on this throw, this line of current is connected. Okay, so it's a double pole, double throw switch. It changes the direction of current, and it can work in the automatic engine, okay? So that it can take different paths in the motor. Okay. I hope you understand the operation, the flow of current here. So the initial switch will be this one. When the current flows here, then the automatic motor can change the direction of the current on itself to the different channels of the current in the circuit. Okay, operating of the double pole, double throw switch. Okay, from the positive terminal of the battery, through the on and off switch. This is the single pole, single throw. Through the top part, okay, which is 1 to 5. Through the motor from N, okay, we go to the motor now, M2 to M1, right? M2 to M1, and then it can go to 6. Through the bottom part, okay, of the switch from 6 to 2, there, from 6 to 2, okay? When this is closed, it goes from 6 to 2 to the negative part of the terminal. Then it goes back here, okay? So this double pole, double throw switches. They can alter the route of current at any time. When it closes here, when 2 connects to 6, then it can take the current back to the negative part of the battery. Okay. I hope that when you look at your ukuqonda MST books, the learner's book, you will get these circuits. And when you have other textbooks, which we hope that the other textbooks that you are using, they have been screened by the department, you can find similar illustrations of the circuits where these components are used. And if you do look at these circuits, you will better understand them. If you do not have these workbooks, Sasol Inzalo workbooks, please download them, check them online, okay? They are the workbooks that the department is using in the subject technology, and the department owns them. They were developed by Sasol Inzalo for the Department of Education, okay? Please expose yourself to these circuits so that you get a better understanding of them. You don't necessarily have to draw this circuit as long as you understand the operation of the circuit, okay? If maybe you are presented the same switches in a different circuit where you will be told that this is how the switch is closed, this pole, maybe pole 1 is lying on throw 5. How will the current move? Then you can predict that. But you will be required from time to time to use these graphic symbols in your circuit diagram, okay? The new graphic symbols that you learned today are these switches. They are a little bit complex, and you also learned their motto, okay? So you must recognize these component symbols. We will be introducing them one by one as we progress with our lessons. And when you know these symbols, you can get an instruction that you must be able to draw a circuit diagram, okay? Then you must remember, what is the graphic symbol of this component? Because here you have your switch, but the graphic symbol looks like this. Okay, for any switch that fits into the category of this, the graphic symbol will look like this. But if then it is a single pole double throw switch, the graphic symbol looks like this. If it is a double pole double throw, the graphic symbol looks like this. You must be able to recognize the graphic symbol. You must be able to remember the graphic symbol in case you are required to draw the circuit. Right, I hope you did understand the switches that you did today. Any questions? Where's my grade 9? Okay. Amra, did you understand? No questions? All right. Okay. So we will be bringing up these circuits in our next lesson when we recap so that you understand. All right? Okay. Thank you. Thank you, Amra. Thank you. And I hope you perform well in your test. All the best for your assessment. For today, that will be all. Thank you very much, grade 9. Enjoy the rest of your day. All the best with your assessment.